The Turkish defense industry has continued to show rapid development in recent years. One of the most ambitious projects that has captured global attention is the development of the Anka-3 stealth combat drone. This next-generation drone is designed to symbolize Turkey's increasingly independent and modern military technology. It boasts a futuristic design, advanced combat capabilities, and a cutting-edge avionics system. Behind the Anka-3 drones, Splendor lies a long and complex assembly line process involving thousands of technicians, engineers, and state-of-the-art manufacturing technology. Each part of the aircraft is precisely engineered to produce a drone that is not only strong and lightweight, but also possesses stealth capabilities. One of the most critical parts of the Anka-3 production is the fuselage assembly line. This area is filled with automated machines and industrial robots working with pinpoint accuracy. The drone's main structure is made from lightweight yet extremely strong carbon composite materials. The use of composite materials is a crucial factor in achieving stealth characteristics. The Anka-3's wing design is one of the most revolutionary elements of this project. The flying wing concept provides high aerodynamic performance and improved fuel efficiency. On the wing assembly line, the internal structure is created using a lightweight titanium frame combined with a special composite layer. After the main structure is completed, the drone enters the avionics integration line. This stage is the centerpiece of the Anka-3's electronic brain assembly. In a high-tech sterile area, technicians install the flight computer, radar, electro-optical sensors, and satellite communication system. Unlike conventional turboprop drones, the Anka-3 uses a jet engine, which provides much higher speeds. The engine assembly line is one of the most sensitive areas of the production process. The engine is installed using a high-precision hydraulic lifter. Technicians then connect the engine's fuel, cooling, and electronic control systems to the central flight computer. One of the Anka-3's main advantages is its internal weapons bay. Unlike conventional drones that carry missiles under the wings, the Anka-3 stores its weapons inside the fuselage. This concept was chosen to maintain stealth characteristics. By storing weapons inside the fuselage, radar reflections can be maximally suppressed. The Anka-3 was developed by Turkish Aerospace Industries, Turkey's leading aerospace company, responsible for various national military aircraft projects. This program is designed to produce a new generation of combat drones capable of conducting reconnaissance, airstrike, electronic warfare, and long-range strategic operations. Unlike previous generations of Anka drones, the Anka-3 features a flying wing design without a vertical tail. This concept was chosen because it significantly reduces radar signature. The fuselage is integrated with the wings, resulting in a stealth profile superior to conventional drones. In the early design stages, Turkish engineers conducted digital simulations using advanced aerodynamics software. Thousands of flight scenarios were tested virtually to ensure the Anka-3's high stability in flight, under various weather conditions and speeds. Before flight, all of the drone's electronic systems were tested in a specialized laboratory. This testing involved electronic warfare simulations to ensure the Anka-3's resistance to enemy signal interference. The radar and electro-optical sensors were tested using simulated moving targets. Technicians ensured the infrared camera and radar could detect targets in various weather conditions. The final stage in the production line is flight testing. Before flight, the drone undergoes a taxi test to check the wheel, braking, and directional control systems on the runway. After all systems are declared safe, the Anka-3 makes its maiden flight under close supervision from the control center. During the flight, hundreds of sensors transmit live performance data to the technical team on the ground. These tests include speed, stability, maneuverability, satellite communications, and weapon simulations. The test results demonstrate that the Anka-3 has very promising combat capabilities and is poised to become a vital part of Turkey's future air force. The development of the Anka-3 drone symbolizes the renaissance of Turkey's national defense industry. The country is now increasingly capable of producing advanced military technology independently without relying entirely on foreign countries. The success of this project also demonstrates Turkey's significant progress in artificial intelligence, stealth technology, digital avionics, and modern aerospace manufacturing. With the launch of the Anka-3, Turkey strengthens its position as one of the world's most influential military drone manufacturers. This drone is expected to play a crucial role in modern military operations, both for reconnaissance and high-precision strike missions. The Anka-3 is not just an ordinary combat drone, but rather a representation of the future of aerial warfare that combines stealth technology automation, and artificial intelligence in one cutting-edge combat platform.